Page 192, problem number 4. A computer company advertises that they sell 60 computers every hour. Well, let's just think about this claim. They're not really saying they sell exactly 60 computers per hour. They mean on average they sell 60 computers every hour. So we want to see whether this claim is true at a 95% level of significance. A sample of a recent 24-hour period gave the following data. So if we look at this data, some of these numbers are less than 60, some are greater than 60. One of these is exactly equal to 60. But we want to see, do we think this computer company really sells 60 computers every hour? So let's start with our hypotheses. Our null hypothesis. Our initial claim is that the average number of computers they sell per hour is equal to 60. And our alternate hypothesis is what we're testing here. So we think that perhaps the average does not equal 60. Okay, so which tests are we going to use? Well, we're comparing an average to a number. So we're either going to use a z-test or a t-test. Well, a few things here. First of all, we don't know a standard deviation, which would lead us to use a t-test. Plus, we have a relatively small sample here. We have 24 data points. So that's going to lead me to use a t-test. First, because we're comparing an average to a number. Second, because there's just some questions about the data we have. No standard deviation and a small sample. Okay, next step is to find the p-value. To do this, we could use a formula, or we could pull out our calculators, which I'm going to do, and let it do most of the work for us. So I'm going to press my stat key. And I'm going to go over to tests, and I want to choose t-test. Now, just a few things here. If we use a t-test, we have to enter in the average standard deviation of the sample. Now, we don't know this average. Well, there's two ways we could do this. We could find this average in standard deviation, or let me show you a shortcut. I'm going to quit out of here. Let me press my stat key and press enter. Now, I've got all of this data entered into list 1. So if we take all these numbers and put them into a list, in this case I'm using list 1, and I took a little shortcut, did it in advance. Then when I press stat, go to tests, and go to t-test, I can highlight the word data instead. Notice then, I'm just telling the calculator my list of data is in list 1. Now I do have to enter some information. First of all, this means our original claim, our original average, which is 60. We are testing the claim that this average is equal or not equal to 60. And that's it. We don't have to figure out my mean and standard deviation. We can let the calculator do the whole thing for us. So when we calculate, again, we're looking at this p-value. Now it tells us the average, tells us the standard deviation, tells us the number of data points. But what we really need is this p, which is approximately equal to, let's see here, it's about 0.648. Now p is a probability, so we can think of this as being the probability that their claim is true based on the data we collected. Or we can, what it really is, it's the percent chance that if we were to run this test over and over again that we'd get an average and standard deviation like we did. Now this is a pretty high p-value. In fact, if this was lower than 0.05, we would reject the null hypothesis. It's not even close to 0.05, so our conclusion will be do not reject the null hypothesis. So based on the data we've collected, we think that the company's claim is pretty accurate, that the average number of computers they sell per hour is right around 60.